Hello. So in your primary schools, you have learned that like poles repel and unlike poles attract. Earlier this year in the topic of electric field, you have learned that like charges repel and unlike charges attract. So today you are going to learn one more. Like currents attract and unlike currents repel. So we are talking about magnetic forces here. If you have two straight conducting wires carrying currents in the same directions, that's what we mean by like currents. So if the currents in the two wires are in the same direction, then the two wires will magnetically attract each other. On the other hand, if the two wires are carrying currents that are in the opposite directions, which is what we mean when we say unlike currents, then the two wires will repel each other magnetically. So let's try to confirm that this is true. Let's think about the wire experienced by wire 1. Why does this wire experience a magnetic force? It's because it's carrying a current in W2's magnetic field. So we must first figure out the direction of the magnetic field set up by wire 2. And for that, we need the right-hand grip rule. So it turns out the magnetic field is going this way. The direction of the magnetic field will be rightward at this point. It will be into the screen at this position, and it's leftward at this position here. But we don't care about the direction of the magnetic field here, or here, right? We're only concerned with the direction of the magnetic field here, where this wire is. So at this position, the magnetic field is coming out of the screen. So let's bring in Fleming's left hand. So magnetic field is coming out of the screen. The current is going up. So it turns out the magnetic force is rightward. See? Wire 1 is attracted towards wire 2. So what about wire 2? So wire 2 is experiencing a magnetic force because it's carrying a current in W1's magnetic field. So you have to figure out W1's magnetic field first. Right hand grip rule. Turns out the magnetic field is this way, which means that the magnetic field is going into the screen at this position here. Take out your left hand, not the vulgar sign, yeah? Fleming's left hand. So magnetic field is going into the screen, current is going upward, magnetic force is left. See? Wire 2 is also attracted towards wire 1. So it's true. These two wires carrying currents in the same direction do attract each other magnetically. Now let me ask you a question. Suppose I1 is 1 milliamp and I2 is 1000 amp. So which magnetic force is stronger? F1 or F2? Did I hear some of you say, same. Same? Really? Can they be the same? So what's F1? BIL, right? What's F2? BIL also, right? But for F1, the B is wire 2's magnetic field and the I is its own current. But wire 2's magnetic field is mu I2 divided by 2 pi r. But for F2, the B is B1, the magnetic field set up by the other wire. And the current is I2, its own current. But what is B1? B1 is mu naught I1 divided by 2 pi r. So do you see you have I2 times I1 here and I1 times I2 here. So these two forces are exactly the same in magnitude. A lot of people will say that this is another instance of Newton's third law. Right? The two wires are exerting equal but opposite forces on each other. I guess that's how some of you could conclude that F1 and F2 should be the same in magnitude without going through all this analysis here. Okay, now let's flip I2 around, yeah? So from both going upwards, we are going to consider what if they are in opposite directions. So unlike currents. So you can do your right hand grip rules and your Fleming's left hand rule all over again, or you can just by logic figure out that the two magnetic forces should both flip, yeah? So just now both currents were going upward and F1 and F2 were like that. So what happens if I2 is flipped around? Let's think about F1 first. Has B2 flipped direction? Yes, it has, yeah? Because I2 has flipped direction. But I0 has not flipped direction, which means F1 should flip direction. So F1 instead of rightward should be leftward now. What about F2? Has B1 flipped direction? No, right? Because I1 never flipped, right? But I2 itself has flipped direction, which means F2 should flip direction. So F2 instead of leftward should be rightward now. So that's right. These two wires carrying unlike currents will magnetically repel each other. Now I think some of you have memorized the resultant magnetic field for like currents and unlike currents. And then some of you have been told that, imagine the field lines as some elastic band that's trying to contract and therefore there's an attractive magnetic force. And then for this one, you were told that, wow, look at all these field lines here, they are very squeezy, right? So these field lines will repel one another and force the two wires apart. That's why there's a repelling force. You know, I'm one person who is very fond of imaginations and visualizations. If you want to use this image to help you memorize the outcome that like currents attract and unlike currents repel, by all means. But please don't use this to explain why the forces are attractive here and repulsive here. For the explanation, you should go back to your right hand grip rule and your Fleming's left hand rule, because you have already learned F equals to BIL. You're doing A-level physics now, you know? Okay, that's all. Ta-ta!